Okay, hello, good morning. So, our focus of discussion for today is harnessing geothermal energy. Geothermal energy harnesses electricity by tapping the heat stored at the Earth's crust. On July 4, 1904, Prince Piero Ginori Conti tested the first ever geothermal power generator in Larderiello, Italy, which was the same place where the first commercial geothermal power plant of the world was eventually built in 1911. In 1958, New Zealand built the Wairakei plant, the first plant to resort to flash steam technology. Later, John Grant from the USA successfully drilled a well at the Geysers Resort and was able to generate enough to power the street lights and buildings at the said resort. This marked the launching of the first large-scale production of geothermal energy in 1960. In 1972, Geothermal Energy Association was formed in order to develop geothermal resources worldwide. At present, as many as 24 countries utilize geothermal energy to produce electricity, while around 70 countries resort to geothermal heating technology. According to the International Geothermal Association or IGA, about 10,750 megawatts of geothermal power in 24 countries are actually in operation, which is expected to generate 67,246 gigawatt hours in 2010, a growth of about 18,500 megawatts by 2015 was also projected by IGA based on the number of projects under consideration. Now, as of 2010, the United States ranked first in terms of geothermal electricity production with 3,086 megawatts of installed capacity extracted from 77 power plants. As mentioned, the largest group of geothermal power plants in the world can be found at the geysers in San Francisco, California. The second largest group of geothermal power plant is located in the Philippines, luckily, with 1,900 megawatts of capacity online. About 27% of the Philippine electricity generation can be accounted to geothermal power plants because we do know that the Philippines belong to the Pacific Ring of Fire, so why not use of this energy that is so free and we have easy access through just tapping the energy that is coming on our Earth's interior, basically on the volcanoes which are highly present not only in the regions of Luzon but likewise on the areas of Visayas and of Mindanao. A geothermal system is described systematically as convecting water in the upper crust of the earth, which in a confined space transfers heat from a heat source to a heat sink, usually a free space. This system is composed of three main elements: a heat source, which is actually the volcano, a magma, or even a fissure or a cracks wherein your magma are actually present. And then a reservoir. So we should have a reservoir or an area wherein there is this, we could reserve this heat that is coming from the volcano or of the magma, and likewise a fluid. A heat source can be either a very high temperature above 600 degrees Celsius, magmatic intrusion, so whenever there is a presence of magma, that could be our heat source that has reached a shallow depth, or which is actually reaching the surface of the earth, or is a visible or not really on a deep deeper part of the continental crust. So it would be very easy for us to dig and to manipulate and somehow explore in use of this magma in this heat source. So the depth should be from 5 to 10 kilometers only, or as in certain low temperature systems. The Earth's normal temperature, which as we understand, increases with depth. So I discussed that one already. As we go to deeper portions of our Earth's interior, the temperature increases. This is due to the number of particles that are actually being compressed due to the weight of those particles or of the huge blocks of rocks on the top is actually compressing those materials on the bottom. So that is why as you go down the Earth's interior, it gets hotter and hotter because of this compression process. And with this high compression of rocks, the thing is that there is this increase in temperature that is occurring on our Earth's interior. The reservoir is a volume of hot permeable. Permeable means it allows material to pass through. That is what we mean by permeable. The reservoir again is a volume of hot permeable rocks from which the circulating fluids extract heat, or this is where rocks and fluid interacts as to transfer the heat that is coming from the heat source. As long as the water remains as water and it will not absolutely go into gas, and likewise the rocks do not melt as a magma, it will serve as a hot permeable reservoir. This component is generally below a blanket of impermeable rocks. So which means we also need an impermeable rock wherein it does not allow material to pass through, and connected to a recharge area through which the meteoric waters can replace for a while, the fluids that escape from the reservoir through springs or boreholes. So this steam, so you have the impermeable rocks, then the permeable, it allows the material to pass through. Then you have the liquid, then the liquid is absolutely being heated up by the rocks. Now the liquid turns immediately into gas or steam. No, this steam has this high amount, the steam holds a high amount of energy or heat energy that can be transformed into electrical energy. So this steam is now collected into tubes wherein it can be transformed into an electrical energy. Finally, the geothermal fluid or water is the carrier that transfers the heat. It often carries with it other chemicals and gas, such as steam that I mentioned a while ago, such as carbon dioxide and hydrogen sulfide, and many others. The mechanism that governs this geothermal system is known as fluid convection. Convection takes place due to the heating and consequent thermal expansion of fluids in a gravity field. So when we speak of convection, this simply explains hot material rises, cold material sinks. Now on this convecting tube in a geothermal power plant, it collects those hot materials that is actually rising up. The mechanism of this cold material that is sinking up somehow recycles the materials inside it, such as the fluid. So when the hot material goes up, it cools down, and then those cold material will then go back and being heated up again. Okay, so heated fluids become less dense, tend to rise, and are replaced by colder fluids of high density, creating a convection current. Now this current itself this current itself can be transformed into an electrical current. Now, geothermal power plant operation. Geothermal power plant is like a regular power plant except that no fuel is burned. So see, this is the most energy saving, plus it releases less amount of pollutants in air. Thus, having this less pollutants of air, somehow the government should see this potential of geothermal energy or power plants to be one of the major source of our electricity here in the Philippines. Because since we belong on the Pacific Ring of Fire, we have an abundance of magma as a resource. All we need to do is to put up a lot of geothermal power plants so as to gather this stored energy and convert it into an electrical energy, so as to lower the amount of the electricity that we pay monthly, and likewise to reduce the number of pollutants as we burn coal to produce electricity and other fuels here in the Philippines, not only here in the Philippines but also in other foreign countries. So the steam in a geothermal power plant is heated by the earth. Like other power plants, they use many of the same components, including turbines, which collects the steam or of the gas, generators, which transforms the heat energy into the electrical energy. And then we have the transformers, which distributes this electrical energy that is being transformed already into electrical energy to different houses and establishments which needs this electricity, and other standard power operating equipment. There are 3 types of geothermal power plants, but the basic mechanism for each type can be summarized using the following diagrams found on your textbook, page 223. So kindly do get your textbook because we will discuss it now. The next is so based from figure 9.25 on your textbook, the basic mechanism that we use on a power plant, on a geothermal power plant rather. Number 1, a production well is drilled into a geothermal reservoir. To allow the return of used geothermal fluids to the geothermal reservoir, an injection well is also drilled. Hot geothermal fluids flow through pipes to a power plant to use in generating electricity. So which means we need to bore holes or wells or these huge holes connected to this hot springs, magma, or even volcanoes itself, so as to collect this steam which can heat up the fluids on our reservoir. Okay, so hot pressurized geothermal fluid or a secondary working fluid is allowed to generate rapidly and provide rotational or mechanical energy to turn the turbine blades on a shaft. So which means the heat energy that is generated from the magma, hot springs, or even the volcano itself is allowed to move through these wells that we bore, or through the wells that we could generate this heat, and then a turbine is connected to collect this heat or the steam from this volcanoes or from the source of the heat. So they are allowed to move through the turbines, and then after the turbine you have the generator. Now, the generator transforms this into a mechanical energy wherein it allows the turbines to move in a circular pattern. Now, this movement of the turbine in a circular patterns allows or transform this mechanical energy into an electrical energy into the transformers. Okay? Thirdly, again, rotational energy from the turning turbine, from the holes that we connected it into the wells, then these wells are actually connected to the main source of heat such as magma, hot springs, or even huge volcanoes, is utilized to spin the magnets inside a large coil and eventually create electrical current. The two primary pieces of equipment used to convert geothermal energy to electrical energy are the turbine and then the generator. So again, the turbine collects this steam that is connected to the heat source. Now, the turbine needs to move in a circular pattern, and then this mechanical energy or this movement or this motion of the turbine in a circular pattern transforms this mechanical energy. So, from geothermal energy, since it moves your turbine in a circle pattern, you have the mechanical energy, then it will be transported into the generator. The generator then transforms it from mechanical energy or this movement of the turbine, circular movement of the turbine, into an electric current. Okay? Lastly, on the fourth one, electrical current from the generator is sent to a step-up transformer outside the power plant. Voltage is increased in the transformer and electrical current is then transmitted to different houses, buildings, and other establishments. So basically, you need only those magma or heat source. Then you have a hole wherein you need to connect those turbines or pipes, and then these pipes need to have a circular motion, and then on that circular motion there you will connect the generator, which will convert this mechanical energy or the circular motion into an electrical current. Now, on the transformers that is connected to the generator, it doubles up this electrical current, and then it is being transported to the different houses and establishment which needs this electricity. Now, we have different types of geothermal energy or power plants. So, firstly, we have the dry steam power plant. When a geothermal power plant uses hydrothermal fluids such as steam in the same form as it comes from the ground, such as what I've discussed a while ago, this steam is actually, since you have a bedrock and then the fluid on top of it, the fluid then is being transformed into the next phase. So from water, it turns into gas. From gas, then next to steam. Now, when we speak of steam, there is no moisture at all. So it holds a high form of energy than that of the gas. So that is the dry steam power plant, wherein it does not hold any amount of moisture. When a geothermal power plant uses hydrothermal fluids such as steam in the same form as it comes from the ground, the plant is called a dry steam plant. Here, wells are drilled into a rock until it reaches the geothermal reservoir or the heat source. Steam reaching temperature of 150 degrees Celsius or more travels directly to the turbine. So which means the turbine is directly connected to the heat source, wherein it is very risky because most of the turbines melts and become part of the magma. So this somehow is really risky because when it melts, then the whole setup needs to be repeated. Okay? Or you need to bore a hole again, wherein it's somewhat distant distant to the heat source so as to avoid melting of the turbine directly. Okay, or right away, it will be melted. So, here, wells are drilled into a rock until it reaches the temperature which is 150 degrees Celsius or more, travels directly to the turbine which drives a generator that produces electrical energy. This type of power plant was the first type to be developed in Italy and is still being used today at the geysers in California. So that's the dry steam because it's the most easiest way. You connect the turbine right away to the heat source. The turbine then moves in a circular pattern. Then the generator converts this mechanical energy or the circular motion into electrical energy. Then the transformer distributes this electricity into different houses. Next is the flash steam power plant. In this type of power plant, water is pumped from the reservoir under high pressure. The pressure keeps the water in its liquid state. Again, it should be again in a liquid state. Despite the boiling point temperature of the fluid with the temperature of 182 degrees Celsius or beyond is pumped under high pressure into a tank at the surface held at a much lower pressure, causing some of the liquid to rapidly vaporize or flash. The vapor then drives the turbine again, so which means it is actually in the form of gas form wherein there is a little moisture because the origin is actually in a fluid form. Okay? So the vapor then drives a turbine which drives a generator. If any liquid remains in the tank, it can be flashed again in a second tank to extract even more energy. So in this scenario, the fluid from the heat source or from the main heat source is used repeatedly. Okay, because we have this convection current. Hot material goes up, then cold material sinks. So some of the materials that is not or some of the gases that is not being used directly into the turbine of this flash steam power plant goes down and then vaporizes again or condenses rather or cools down and becomes liquid again and then being used to the second tank, and then on the second tank there it will be heated up again and then be transformed into a vapor form, and then the vapor is then transported into the turbine again and then generate mechanical energy or move the turbine in a circular pattern. So in a fluid or flash steam power plant, it's very convenient because it is not directly connected to the heat source. Rather, it pumps water under high pressure. Then this water is converted into gas repeatedly, and then the gas is used to run the turbine. So it's very convenient. This classification of geothermal power plant is very useful. Now, binary cycle power plant. A binary cycle power plant operates differently from dry steam and flash steam plants, as this type does not use water or steam to turn the turbine blades for power generation. Here, geothermal fluid at low to moderate temperature, approximately 107 to 205 degrees Celsius, is used to heat a separate fluid that has a boiling point lower than that of water. So it must be a different type of liquid other than that of water, because water boils at a temperature of 100 degrees Celsius. When this fluid is vaporized, the vapor or flash is used to turn the turbine blades again into a circular pattern and subsequently run the generators. Okay, and then the generators the transformers rather distributes the energy or the electricity generated from the generators. Okay, so that's all for today. Goodbye and thank you, class. I hope you learned something new for today. Goodbye and thank you, class.